I was 16 years old when I first learned about composite materials. So I went to the States. I got my undergrad in composites, got my master's in biocomposites, and then I worked for 3 years managing projects for some of the biggest mobility players in the world, John Deere, Caterpillar, and even did a project for Kinkishario from Japan. Here I am to tell you guys about my journey through my company, Midwest Composites, where we sustainably engineer biocomposites. So one of the main problems that we notice in the world is vehicle manufacturers are looking for green and sustainable materials. Synthetic fibers such as carbon and glass fibers are filling landfills and not recyclable. The existing global supply chain are focusing on flax and hemp fibers, while other natural fibers such as kanaf, jute, pineapple, banana, and bamboo are not being explored. Flax and hemp fibers are quite expensive because the supply chain is kind of pushing for that. So these alternative fibers are a good solution to replace them also. So we've come up with a high performance natural fiber textile mat, which is 70% the strength of glass fiber. It reduces your carbon emissions by 75%. It gives you vibration dampening advantages. It's very aesthetically pleasing, and they can be impregnated with thermoplastic and thermoset resins. It's also a very good insulator. This is roughly how it works. You grow the fibers such as flax, kanaf, jute, hemp, sisal, abaca, banana, pineapple, and even coir, which is coconut, convert them to the midstream to these natural fiber textile mats, which then can be converted into interior and exterior components for buses, cars, planes, and then we hope for them to go through a circular economy. So what we're doing is we're replacing glass and carbon fibers and sometimes hybridizing them with these natural solutions. So why are biocomposites so interesting? They give you a 40% weight reduction from conventional metals, which in turn increases your fuel efficiency and assembly efficiency. It decreases your lifetime maintenance costs because it's very non-corrosive and it can withstand the weather. And again, it reduces your greenhouse gas emissions significantly. Planes currently use about 50%, whereas cars, buses, and trains are only using 6%. This is the gap in the market that we would like to take advantage of, especially when the EV sector starts looking for more and more sustainable and green materials, as is what's already happening in the market at this moment. The market side for biocomposites in 2030 is 125 billion. We're playing in the transportation market, which is a $36 billion market. APAC, our region, is a $13 billion market, and Southeast Asia, our locality, is a 3.25 billion market. There are other biocomposite startups in the world. One's in Canada. They focus on hemp fibers and they're building for recreational vehicles. And then you have Ecoa Bilingrove in North America, who focuses on flax fibers, and they've actually built components for Hyundai at the moment. And then you have Bcomp, the market leader. They've raised a lot of money focusing on flax fibers. They've worked with BMW, Airbus, Volvo, and most of the biggest players in Europe. And then there's us in Asia, Midwest Composites. We've raised 100,000 pre-seed money from Indelible Ventures at Scale Up Malaysia. We focus, as I said, on kanaf, palm, jute, and we're doing research on pineapple, banana, and bamboo at the moment to increase our natural fiber staple. So what we see that we can do with Makinohara is working together with the M2 Labo. So we could help them build world-class components that are sustainable, such as their Labo Mobile rover, such as how we've already done projects for other customers in Malaysia at this moment. We could also work with Kasahara Sangyo so that their vehicle exterior and interior components can also be converted to these sustainable materials. Obviously, we could work with Suzuki. They build a lot of vehicles, and this would be very beneficial for both. And then we could work with the JA Group, and we could do R&D with tea farms and other agricultural farms to convert all this into biocomposites. So potentially we could use tea waste, or we could even convert some of the empty tea plantations to either kanaf and jute to stimulate the economy so that these kind of biocomposites can be used in these equipments. This is roughly how it would work. You take the waste products that come from the tea, you could grind them up, you could use them as long fibers, and then you could make consumer goods, which basically are tables, chairs, and even souvenir items. And obviously, we could also make bus components, car components, motorcycle components, and aerospace components, and run through a circular economy, like I said. Our team's been working on this for quite a long time. We have a lot of experts, especially in the natural fiber materials. And then we have good business advisors. We've been participating in a lot of accelerator programs around the world, the JAC World from Europe, Journal of European Composites, who were the Asian Startup Booster Top 5, The Germans invited us for the Startup Germany tour. We were also the regional champions for Malaysia and were sent to San Francisco for the Startup World Cup. We've been to Vietnam, Petronas Future Tech, Hyundai Cradle. We've been getting a lot of grants and awards from the Economic Research Institute of ASEAN and East Asia and UNDP and different Malaysian agencies. So we've built a shopping cart, which was 20% renewable and reduced 32% of the weight for the customer, which reduced 68% GHG emissions, which made them very happy. We've built drone components using the same materials and reduced the carbon emissions significantly for the customers. We've built bus components. We've built components for race cars for universities here. And we've also built the 50th anniversary torch for Petronas. We built souvenir items for FGV, and we've been building tables and chairs, like we said. We're looking for 1.5 million, which would help us increase our footprint and grow our business even bigger. And this is our dream for the future, where what we're building is being used for space travel. Thank you.
Okay, thank you very much. Great presentation.
Thank you.
Okay, someone have a good question from the judges? No? Okay, so I'd like to ask one question. Okay, you know, in our sponsors, the company named Itoin, they are producing the you know, the bottling tea. Bottling tea. They are you know, suffering about the, you know, producing the tea waste. Okay. So can you use tea waste? You show that you can use tea waste as your material, right? So maybe I think the Itoen would be the you know, potential great your, you know, collaboration partner in Japan. How do you think about it?
Oh, I think it's an excellent idea, because if we can receive the raw material from them, then we could actually try to incorporate that into the products that we're building. And then from that, we would understand the viability of how this project could work. And that would be a very good stepping point for us to step into Makinohara and for Makinohara to benefit from our experience and our technology.
Okay. So you showed the some other you know, potential partners as like M Square Labo or others, you know, Suzuki or others. But if possible, you would add the Itoen with your as your potential collaboration partner. Okay, so okay, yeah, we will introduce you. I'm very happy to introduce you them for as your partner. Okay. So,
please.
please.
So yeah, thank you for your presentation. So I want to know how strong is your material compared to the steel or aluminum?
Okay, so at this moment, our natural fiber materials, if we're using the long fibers such as kanaf, jute, flax, or hemp, we can get it at the same strength of steel. But when we use shorter fibers, such as how tea leaves and all these things would be, then the strength would be much lower. But the shorter fibers, especially like tea leaves, we could use them for non-structural components, interior components of your vehicle. So if we use the long fibers, then we can make exterior components too.
Okay, thank you. And one more question: is mass production also possible? Your material?
So for long fibers, the moment you convert them into the mats, you can replace carbon fiber or glass fiber. It's going to be very similar processing. If it was shorter fibers, then you basically mix it straight into the resin and you can injection mold it or, you know, compression mold it. So it shouldn't be so difficult. There are many players already playing this with different additives that are not natural. So what we're doing is using natural additives. Yeah.
Okay, yeah. Thank you so much.
마켓 찰레 심사위원 여기 시장님.
Okay, thank you very much.
Thank you.